Here's another rational expression that we're asked to simplify and state the values that are excluded from the domain because they make the expression undefined. So they make the denominator equal to 0. So in order to do this, the first step we're going to have to do is to factor both the numerator and the denominator. So let's look at doing that. In the numerator, we've got a negative 16c term. So what we need to do is list our factors of negative 16. So that's 1 and negative 16, negative 1, positive 16. Do either of those have a sum of negative 6? So this would be negative 15, positive 15. So neither of those work. So let's try 2 times negative 8 and negative 2 times positive 8. Those factors are have a product of negative 16. So this one right here, 2 and negative 8, does have a sum of negative 6. So therefore, this numerator is going to factor into x plus 2 times x minus 8. So this is the product of two factors. In our denominator, we need to do the same thing. We need to factor this. So our factors of positive 6, we've got 1 and 6 and 2 and 3. Of those two factor pairs, 2 and 3 has a sum of 5. So therefore, this factors into x plus 2 times x plus 3. And don't forget, when you're factoring, it's a great idea to always go back and double check to make sure you factored correctly by foiling and multiplying it back out to see if you get the original expression. So x times x is x squared, x times negative 8 is negative 8x, 2 times x is 2x, negative 8x plus 2x is the negative 6x, 2 times negative 8 is negative 16, so we're good there. And down here in our denominator, x times x is x squared, x times 3 is 3x, plus 2 times x, which is 2x, and that would be 5x, and 2 times 3 is 6. So we factored this all correctly. Now we could reduce this, but before we do that really quickly, let's figure out what values x cannot equal. If this factor equals 0, if we substitute in some value for x and it makes this factor equal to 0, it doesn't matter what this expression equals, or this factor equals, because 0 times x plus 3, whatever this equals, will always equal 0. Or if x plus 3 were to equal 0, if we plug in or substitute a value in for x that makes this factor equal to 0, then it doesn't matter what x plus 2 is. X plus 2 times 0 is also going to equal 0. So what we need to do is we need to figure out what value of x makes x plus 2 equal to 0, which is pretty easy. We just subtract 2, so x equals negative 2. So we cannot substitute in negative 2 for x. Negative 2 is excluded from the domain because that's going to make this factor equal to 0, which will make the product in our denominator equal 0. We also have to figure out what value of x makes this factor, x plus 3, equal to 0. So that's also pretty straightforward. We're left with x equals negative 3. Therefore, x cannot equal negative 3 either. For the same reason, negative 3 will make this factor equal to 0, which will make the product in our denominator equal to 0, which will make the expression undefined. So we've done this second portion. We've stated the values of x that make the expression undefined. Our last step now is to reduce or simplify. So we look for any common factors here. So x plus 2 and x plus 2. That simply reduces to 1 over 1, or 1. So in our numerator, we're left with x minus 8 over x plus 3 in our denominator. Again, even though x divided by x is 1 over 1, because these are not factors, we cannot reduce them because we can't reduce x over 3, and we cannot reduce negative 8 over x. So we're finished with reducing. Our last step is to state what values are excluded from the domain. That would be x cannot equal negative 2 or negative 3, and we are finished. This is our final solution.